Hello students, today we are going to discuss class 11 chemistry chapter number 12 NCERT exercise solution. So let's start with question number 1. What are hybridizations? State of each carbon atom in the following compounds: CH2 double bond C double bond O, CH3 CH double bond CH2. First of all, what you have to do, you have to just draw the structure of these compounds as it is represented. You can see on the screen CH2 double bond C double bond O. You have to just find out the hybridization between the carbon-carbon atoms. So I had informed you that if there is a double bond between the two carbon atoms, then there will be a hybridization called sp2, and when there will be triple bond, then I have said you sp, but here there are 4 bonds, then also it will be sp, hybridization of the second carbon atom. Similarly, you have to just remember that if carbon is having a single bond, then they will have sp3 hybridization. If carbon is having double bond, sp2 hybridization, triple bond, sp hybridization, and here 2 double bonds, then sp hybridization. Hope all of you have understand the first question. Now we are moving towards the second question, that is indicate the A and N bonds. Here A means sigma and N means pi. Okay, so here you have to just say that how many sigma bonds are there and how many pi bonds are there in this compounds. Just a second, you can see the second question in your screen. That in the second question, what we have to just say that how many sigma bonds and how many pi bonds are there. So here you can see that if there is this is the structure of benzene. Yes, in the benzene there are 3 double bonds between the carbon. It is a cyclo. In the cyclo there are triple bonds called benzenoid carbons. So here you can see in the benzenoid 1 sigma, 1 pi, 1 sigma, 1 pi, 1 sigma, 1 pi, right? And the carbon hydrogen atom will contain sigma bonds. So here you can see there will be carbon atoms. If I talk about between the carbon, there are total 6 carbon atoms, but as you go ahead in the pi and sigma, there will be 5 pi and 5 3 sigma, and total 1 2 3 4 5 6 sigma of the carbon bonds and 3 pi bonds. And if you talk about the carbon hydrogen sigma bond, there will be 6 carbon hydrogen sigma bonds. Now we are moving towards the ahead that in the next question, CH2Cl2 means dichloromethane. You can say in the dichloromethane there are 4 sigma bonds. Next you can go towards that there are 2 double bonds in a pro 1,2-diene. So here you can see between the carbon atoms 2 sigma 2 pi and carbon hydrogen 4 sigmas. If I talk about CH2NO2, you can see first of all, as I had informed you, that's a lone pair one is dative bond, right? And the nitrogen can have maximum 3 bonds, but if the next bond is coming, so oxygen can share maximum 2 bonds. So here you can see in the nitrogen one is shared 2. So when that 2 bonds are there, one will be sigma, another will be pi, and that is dative bond, which is arrow towards the oxygen atom. And then the carbon, if we are talking about, then the carbon will have 4 sigma bonds, carbon hydrogen 3 and carbon nitrogen 1 sigma bonds. Next structure you can see that CH2NH CH3. So CO means double bond, 1 sigma 1 pi. In hydrogen 1 sigma, in nitrogen 1 sigma. Nitrogen will have 3 sigma, 2 with carbon, 1 with hydrogen, and here methyl group CH3, 1 attached with the nitrogen atom, 4 sigma bonds. Right? Now we are moving towards the next question, question number 3. Question number 3 is write bond line formula structure for isopropyl alcohol, 2,3-dimethyl butanol and heptane 4-on. What you have to do, you have to just draw the structure. Isopropyl, iso means you know very well, one is branched carbon atom, and that is isopropyl alcohol means OH functional group. So 3 carbon atoms are there, and in the 3 carbon atoms you will see there is one branched, and in that branch alcohol group is there, right? So this is isopropyl alcohol structure, 2,3-dimethyl butanol structure, and heptane 4-on heptanol structure. So now we are moving to the question number 4. We are to give the IUPAC name of this compound. Here you can see the benzene group is attached with the propyl group. So you can say propyl benzene. Second one is 3-methyl pentane nitride. Third one C is 2,5-dimethyl heptane. D structure is 3-bromo 3-chloropentane. E structure is 3-chloropropanyl. F structure is 2,2-dichloroethanol. Sorry, it's not 2,2-dichloro. Here one structure is missing. This E1, F1 here you have to draw the structure. First of all, in the E that was right, 3-chloropropanyl, but in the F the structure is not drawn. You have to draw a line structure, okay? So as you draw a line structure, since in this question we have to write IUPAC name, so just write 2,2-dichloroethanol. Now we are moving towards the question number 5. Question number 5, your names are given, you have to just inform that which name is correct one. 2,2-dimethylpentane or 2-dimethylpentane. You know very well, if there are di means 2 times. So 2 times 2 should be there. So the first one is right. Second, 2,4,7-trimethyl-octane or 2,5,7-trimethyl. So the nearest position 2,4,7-trimethyl-octane is right. Right? For 2 alkyl groups on the same carbon atom, its locate is repeated twice. Okay. So this was the B answer, and if we are moving towards the C answer, 2-chloro-4-methylheptane, right? C1 you can see 2-chloro-4-methylheptane or 4-chloro-2-methylheptane. Yeah, very important. This question is always remember here prefix chloro is there, and chloro will be from the nearest side. So 2-chloro-4-methylheptane, and in the alphabetical order also you have to remember first C comes and then M comes. Next one, but3-ine-1-ol or but4-ol-1-ine. Yeah, very important question is this. If we move towards, then here you can see on the third position triple bond is there, and the first position alcohol is there. Lower locant of the principal functional group, that is alcohol. So alcohol is on the first position and triple bond is on the third position. So the right one is but3-ine-1-ol. Okay. Now we are moving towards the question number 6. You have to just draw this homologous series. Means here formic acid is given, you have to draw acetic acid, propanoic acid, butanoic acid, pentanoic acid. Similarly, you have to draw all the structures. Now we are moving towards another question. Question number 7. You have to just draw the line and condensed formula and functional group. Which condensed formula is present, which bond line and which functional group is present. You can see here in this structure that is given that first question is 2,2,4-trimethylpentane. 2,2,4-trimethylpentane. So here in the second position you can see that first position CH3, second position C, third position CH2, fourth position CH, fifth position CH3, and here on the first position only I have to show you that there is 2-dimethyl. So this here on the second carbon it will give you a 2-dimethyl, and the bond line structure will be represented as this. So as seeing the bond line formula, you will be always able to remember the IUPAC name. So this is 2,2, and on the fourth position also one methyl group is there. So 2,2,4-trimethylheptane, 2-hydroxy. You can see second structure, you can see there's a very difficult structure. So in the B you can see here 2-hydroxy, 1, 2, 3 propane tricarboxylic acid. Very difficult structure, but you have to remember 2-hydroxy means on the second position OH group is there. First, second and third position propane tricarboxylic acid, 2-hydroxy propane tricarboxylic acid. So first of all, what you have to remember? You have to remember that there are total how many? 3 carbon atoms are there. First, second and third. On the second position you have to put OH, and first, second and third position you have to put COOH, that is carboxylic acid. So here you can see the structure, line, bond formula, and the functional group present on this compound is alcohol and hydroxy. Sorry, that alcohol is also known as here hydroxy, and this carboxylic acid COOH, right? So now we are moving towards the next question. The C1 is CHO aldehyde group is present, right? You can draw the line structure like this, and its name is hexane diol. It's 2-time aldehyde group is there. Hexane diol means diol means both the side first position. Since you must remember that hexane is there, so one will be on the 5th position and another will be on the 6th position. From wherever you count, both the sides the numbering will be the same. So that's why you can write this as a hexane 1,6-diol also, or hexane diol. Okay. So the functional group is aldehyde. Question number 8. Identify the functional group in the following compounds. Which functional group is there? You can see here CHO means aldehyde, OH means here hydroxy, and OME. Can you tell me OME is also known as? Can anybody tell me what is OME known as? Anyone? It's called phenolic ether. You know, ROR is called ether. In the R side benzene is attached and this side methyl is attached. So ROR, so you can say as a phenolic ether. Second one you can see here, NH2 is a primary amine, right? And that RCOOR, you can see both the sides, one side benzene is attached, another side ethyl nitride is attached. So here RCOR, you can say ester group is there, and NCH2, C2H5, C2H5, and here CH2, means all the three side alkyl group is attached. So this will be known as a tertiary amino group. Next one you can see here, ethylenic double bond, means this is a ethylene functional group which is having a double bond, and nitro, NO2, you know very well, nitro group. Here this is a very important question, which of the two, O2N CH2 CH2O minus or CH3 CH2O minus is expected to be more stable, and why? Very important questions. So how you will know this question? First of all, you have to draw the structure, and after drawing the structure, here you can see the arrow mark. Why they are strong? Because nitro group has negative inductive effect, and the second one is having positive inductive effect. You know very well what is negative inductive effect and positive inductive effect. So here, as the positive inductive effect is there, therefore it tends to intensity the negative charge, and hence they destabilizes it to the structure. Okay. Now we are moving towards the question number 10. Explain why alkyl group act as an electron donor and when attached to a pi system. Due to hyperconjugation, you know very well, when alkyl group is attached to a electron donor means, you know, electron donating group, then what will happen? This pi system, you can see here the structure of propene. In the propene, prop 1 first position double bond is there. As I had informed you in the hyperconjugation, that hydrogen removes and that double bond shifts towards the first carbon atom. So here you can see the double bond has shifted, and again this double bond has shifted and the negative charge has gone to that side, first position. So this is called a hyperconjugation. So due to the hyperconjugation, alkyl group act as an electron donor when there is the attachment of pi system, as you can see in this structure. So now we are moving towards the next question. So here the question number 11 is, draw the resonating structure of the following compound. Show the electron shift using the curved arrow notation. C6H5OH, phenol. Phenol, you have to show the resonating structure. I taught you that plus R effect and minus R effect, both the resonating structure. As you can see, the nitrobenzene and phenol resonating structure. Next one is butene-1-ul. Here the lone pair 1 oxygen resonating structure. You can see benzaldehyde resonating structure. You can see benzyl carbocation structure. You will see benzene carbocation. How these electrons are being transferred. So you have to remember that positive plus R effect and minus R effect. This is nothing. I hope that while teaching you about this resonating structure, you all have remembered. Now we are moving towards the question number 12. What are electrophile and nucleophiles? Explain with example. Electrophile means, have you remembered the electrophile? Electrophile means when the electrons are removed, the electron is taken away from this element. So that's called electrophiles. And when electron is deposited, means it is getting a negative charge on it, that's called nucleophile. Electrophiles will have positive charge and nucleophile will have negative charge. So electrophiles, you can say they are electron loving, and nucleophiles you can say nucleus loving. So both the examples, H plus Cl plus Br plus N2 plus R3C plus Rn2 plus AlCl3 Bf3 means electron deficient compound is known as electrophile. An electron rich compound like Cl minus, Br minus, cyanide minus, alcohol minus, RcR2 minus, NH3, RNH2, H2O, ROH, these all are nucleophile compounds. Now we are moving towards the next question. Question number 13. Identify the reagent shown in the bold in the following equation as nucleophile or electrophile. You have to just say that it is a nucleophile or electrophile. So acetic acid plus OH minus ion. So when this acetic acid will remove H plus and CH3COO minus. So this CH3COO minus, you know very well what happens here. minus charge is there, electron is already having a lone pair electrons, so this will be nucleophile, right? CH3COCH3, propanone, right? So this propanone, you will again, as this propanone will break and the cyanide group will attach, what will happen? Again the negative charge will be there, so that's why these both are nucleophile. And C6H5, you know already it will have a positive charge on it, C6H5COCH3, so here it is having a positive charge on it, so the C1 is electrophile. Classify the following reactions in the one of the reaction types studied in this unit. CH3CH2Br plus HS minus, so it will become CH3CH2SH plus and Br minus. You have to just means nucleophilic substitution and electrophilic substitution. As I informed you about that, what is electrophile and what is nucleophile substitution, you can write these answers very clearly. What is the relationship between the members of the following pairs of the structures? Are the structures of geometrical isomers or resonance contributor? Very, very important questions, dear students. You have to just say that which one is structural and which one is geometrical. In the structural, I have informed you there are total 4 types of structural isomerism. If you remember, chain, positional, functionals and metamerism. And tautomerism is also there, but I have taught you in that last video. And here in the geometrical, optical, and second one is in the stereo, geometrical and optical, right? So here you can see the first one structure, it is a positional functional group, right? In the positional difference, so this is a structural isomers. That D1 you can see the second question is called geometrical, because you can see cis and trans relation is given, right? Cis and trans relation is given, so that's called geometrical. And third one again you can see here that there is a double bond OH in which positive charge is there and it has been shifted, so this is a resonating structure of this one, right? So this was our question number 15. Now we are moving towards the question number 16. For the following bond cleavage, use curve arrow to show the electron flow and classify each as a homolysis or electrolysis. Identify the reactive intermediate product as a free radical, carbocation and carbanion. So here you can see the structures and you have to just note down that which one is a free radical and by the arrow symbol which side the whole electron will go or one electron. First structure you can see CH3O and both the side the oxygen. So it is a homolytic, so one electron both the OCH3 will take. So as you can see in the answer that here half fish arrow is given, homolysis is given, and both the oxygen atom will get one electron. CH3O, you can see CH3O and dot is there. That dot means here because a single bond is formed by the 2 electrons, so 1 electron is shifted both the atoms. So this is also called free radicals. In the second structure you can see here the OH minus atom is going to attach. So here hydrolysis is happening. You can see the propanol. In the propanol, one carbon is having negative charge plus H2O. So this negative charge is known as carbanion, and since they are different groups, so here you can see it is a heterolysis. In the third one you can see here that total there is central carbon atom attached with 1, 2 and 3 carbon atoms, and one side it is attached with bromine. So bromine will get a negative charge on it and this methyl group get a positive charge on it. So as there are 2 different atoms, so it will be known as heterolysis, right? And the last benzene plus 1 electron you have given, so this 1 electron will be again giving a positive charge on it, so it will be known as a carbocation group. Now we are moving towards the question number 17. Explain the terms in the inductive and electrometric effects. Which electron displacement effect? Explain the following correct order of the acidity or carboxylic acids. So first of all you can see what is inductive effect as I have taught you. So what will be the intervening effects in these compounds? You have to just arrange these compounds into the correct order of acidity. So here you can see that first one, inductive effect refers to the polarity produced in a molecule as a result of higher electronegativity of one atom compared to the another. Atoms of group or which loses the electron towards the carbon atom are said to have a positive inductive effect. Those atoms of group which draw electrons from the carbon atom are said to be a common example of negative inductive effect. So here negative inductive effect and positive inductive effect, you have to just arrange it according to the strength of acidity, right? So here you can go through it. multiple bonds are there which are approaching to the reagents. So here you can see, as I'm going to show you again here, just wait for a second. You can see that what is positive inductive effect and negative inductive effect. The questions are given here. Cl3CCOH is greater than Cl2CHCOH is greater than ClH2COH. The second one, CH3CH2COH is greater than CH3 all twice CHCOH is greater than CH3 all thrice COOH. So this acidic strength is given here, and you have to just explain about the inductive effect intervening formations as it approaches to the agent. So here you can see, as I have written here about the two compounds, reagent, how this electron fusion happens. As it shares its electron, B will gain its electron, B will get a negative charge on it, A will get a positive charge on it. As B is gaining negative charge in minus inductive effect, and as the carbon loses its electron, so carbon will get a positive inductive effect. So here you can see how this positive inductive effect increases the acidic strength or decreases accordingly. Please note down this structure in your notebook. Give a brief description about the principles of the following techniques, taking an example in each case: crystallization, distillation, and chromatography. Crystallization is the process in which the impure solid is dissolved in the minimum volume of a substance or a suitable solvent. The soluble impurities pass into the solution while the insoluble ones are left behind. The hot solution is then filtered, allowed to cool undisturbed till crystallization is complete. The crystals are then separated from the mother liquid to the filtration and then dried. So these are the examples of crystallization. You can say sugar crystallization. Distillation. The operation of distillation is employed for the purification of liquids from non-volatile impurities. The pure liquid is boiled in a flask and vapors or forms are collected and condensed to give back a pure liquid in another vessel. Simple organic liquids such as benzene, toluene, xylene, etc. can be purified. So these are called distillations. Chromatography is based on the principles of selective distribution of the component or a mixture of between the two phases, a stationary phase and a moving phase. The stationary phase can be solid or liquid, while the moving phase is a liquid or gas. When the stationary phase is solid and basis in the absorption, and when it is the liquid, the basis is partition. Chromatography is generally used for the preparations of colored substances such as plant, pigments, or dye stuffs. Now we are moving to the next question, question number 29. Question number 29 is: describe the method which can be used to separate the two compounds with different solubilities in a solvent. Fractional crystallization will be used because as a hot saturated solutions of the two compounds, when they are being cooled, the less soluble compounds will form crystallization and the more soluble will remain to the solution. The crystals are then separated from the mother liquid, and the mother liquid is again concentrated and the hot solutions are again allowed to cool. When the crystals of the second component are also obtained, these are again filtered and dried. Question number 20. What is the difference between the distillations and distillation under reduced pressure, steam distillation? Distillation is used in the case of volatile liquid mixed with non-volatile impurities. Distillation under reduced pressure, this method is specially used to purify such liquid which are having very high boiling points and which decomposes or below their boiling points. Steam distillation is used to purify the steam volatile liquids associated with the water immiscible impurities. Now we are moving to the question number 21. Discuss the chemistry of Lasagne's test. Lasagne's test means especially it is for nitrogen, sulfur, and halogen and phosphorus which are present in an organic compound. It is detected by Lasagne's test. First of all, the compound are converted into the ionic form, fusing the compound with sodium metal. As for example, as I had informed you, when organic compound which is contain nitrogen, so sodium will react, so sodium cyanide will get. Similarly, if sulfur is there, sodium sulfide, sodium halide. Cyanide, sulfide or halide of sodium are extracted from the fused mass by boiling it with the distilled water, and this extraction is known as sodium fusion extract. Differentiate between the principle of estimation of nitrogen in an organic compound by Dumas method and Ketchup method. With the help of this both the method, we can calculate the volumetric analysis of nitrogen. So the organic compound is heated strongly with the excess of cuprous oxide in an atmospheric of carbon dioxide when free nitrogen, carbon dioxide and water are obtained. It is in the Dumas method, and in Ketchup method, a known mass of organic compound is heated strongly with the concentrated sulfuric acid, a little potassium sulfate and a little mercury as a catalyst. As a result of this reaction, the nitrogen present in the organic compound is converted to the ammonium sulfate. And both the formula I have given you to write, right? So don't forget to write the formulas also here. Discuss the principle of estimation of halogen, sulfur and phosphorus present in an organic compound. So the estimation of halogen, it is involved in oxidizing the organic substances with the fuming nitric acid. In the presence of silver nitrate, the halogen of the substances is thus converted to silver halide and then separated with the weighted. So one weight of organic compound you can write as a WGM, weight of the silver halide XGM. So percentage of halogen, have you remember? X upon X plus 108 into 100 into X upon weight of silver halide and the weight of the compound. Estimation of sulfur. These are all the formula I have given you to write. So if you write the formula also and you have to just elaborate these formulas, very easy. The percentage of phosphorus also. If you have remembered, then have you remembered NH4 2 P2O7 or PO4, right? Now we are moving towards the principle of chromatography. This is the simplest form of chromatography. Here is a strip of paper act as an adsorbent. It is based on the principle which is a partially adsorbent. The paper is made of cellulose fiber which the molecules of water absorb. On them the act has a stationary phase. The mobile phase is the mixture of the components to be identified, prepared in a suitable solvent. Why is nitric acid added to the sodium extract before adding silver nitrate or testing halogens? Nitric acid is added to the sodium extract so as to decompose. You can see here the reactions. You must write the reaction. Don't forget to write the reactions. Explain the reason for the fusion of organic compound with metallic sodium and testing nitrogen, sulfur and halogen. The same that was the above question. That which type of compound you will get: sodium cyanide, sodium sulfide, sodium halide, and if you react with phosphate, then it will get sodium phosphate. Since all are the ionic compounds and become more reactive, and thus they can be easily tested by the suitable reagents. Name a suitable technique of the separation of the component from the mixture of calcium sulfate and camphor. Can anybody tell me? Calcium sulfate and camphor. Camphor, sublimation, right? Sublimation, because camphor can be sublimed where calcium sulfate does not. There are two substances, volatile or sublimable or non-sublimable, you can say. Explain why an organic liquid vaporizes at a room temperature, because its boiling point is in the steam is distillation. Because it is steam distillation and the sum of vapor pressure of organic compound and the steam should be equal to the atmospheric pressure. Will carbon tetrachloride give the white precipitate to when it reacts with silver chloride or heating with the silver nitrate? No, carbon tetrachloride is completely non-polar covalent compound, whereas silver nitrate is ionic in nature, therefore they are not expected to react and a white precipitate silver chloride will not be formed. Question number 30. Why is solution of potassium hydroxide used to absorb carbon dioxide evolving during the estimations of carbon present in an organic compound? Carbon dioxide is acidic in nature and therefore it reacts with strong base KOH to form K2CO3. So potassium hydroxide plus carbon dioxide, potassium carbonate plus water. Why is it necessary to use acetic acid and not sulfuric acid for acidification of sodium extract for testing sulfur by lead acetate test? This was a very important question. I hope one of the students may have asked while explaining also. For testing sulfur, sodium extract is acidified with acetic acid because lead acetate is soluble and does not interfere with the test. So here you can see the lead acetate plus sulfuric acid. You will get a lead sulfate plus acetic acid, right? Question number 32. An organic compound contains 69% of carbon, 4.8% of hydrogen, the remaining being oxygen. Calculate the masses of the carbon dioxide and water produced when 0.20 gram of compound is subjected to complete the combustion. Don't forget to write the formula. As I had informed you, the formula will be 12 by 44 into mass of the carbon dioxide, mass of the compound taken into 100, right? So mass of the carbon dioxide you have to find in this chapter. Percentage of carbon is, you have to find in this question, percentage of carbon is given, you have to just find mass of the carbon dioxide form. It's very easy, 0.506. Similarly, if you have to find the mass of the water compound, if the percentage of hydrogen is given, so easily it can be calculated, 0.0864. I hope while in the explaining of questions of this carbon and hydrogen volumetric analysis, I have given these two same questions. So here question number 33, 0.50 gram of organic compound was catalyzed. The ammonium evolved in the passage of 50 centimeter cube of ammonium sulfate. The residual acid required 60 centimeter cube of N by 2 NaOH solution. Calculate the percentage of nitrogen in the compound. Same question is present in the NCERT in text. So first of all, see here how it has been calculated. Many of the students may having doubt while in the scheduled task. So volume of sodium hydroxide solution required 60 centimeter cube. Normality of sodium hydroxide 1 by 2N. Normality of sulfuric acid 1N. Volumetric unused can be calculated by applying normality. N1 V1 is equal to N2 V2. So here you can see sulfuric acid 1 and sodium hydroxide 2, right? So 1 into V is equal to 60 upon 2. You can ask me, sir, what is this 60? The sodium hydroxide volume is given. So 60 by 2, that is 30 centimeter cube. Second step, you have to calculate the volume of acid used. Volume of acid used is given in the question for 50 centimeter cube and unused is 30 centimeter cube. Right now only we have calculated unused one, that was 30. 50 minus 30, that is the acid used, that is 20 centimeter. Total was 50, 30 was unused, so used one will be 20. Now calculate the percentage of nitrogen by using the formula 1.4 into volume of acid used, normality of acid used, or you can say that 2 into V minus V1 by 2 upon the mass of the compound taken. 1.4 into 20 into 1 upon 0.50, that is 56%. Question number 34, 0.3780 gram of an organic compound gave 0.5740 gram of silver chloride. In the curious estimation, calculate the percentage of chlorine, percentage of halogen 1. X is equal to 35.5 upon 143.5 into mass of silver chloride upon mass of compound taken into 100. So just put the formula and utilize this. Answer is 37.57. In the estimation of sulfur by curious method, 0.468 of an organic sulfur compound gives 0.668 gram of barium sulfate. Find the percentage of sulfur in the compound. Same, just use the formula percentage of sulfur, 32 by 233 into mass of barium sulfate upon the mass of compound into 100, right? 19.60. Question number 36. In the organic compound, here it is given CH2 double bond CH, single bond CH2 CH2, carbon triple bond CH. The CH-CH2 bond is formed by the interaction of a pair of hybrid orbitals. CH-CH2 bond. CH-CH2 bond, you have to just say that which one is the correct hybridization. First of all, draw the structure. Double bond will have sp2 hybridization, single bond will have sp3, and triple bond will have sp hybridization. So you can go through. The right answer is the C1, sp2 and sp3. Double bond and single bond. You can see double bond one carbon will have sp2 and CH2, that is single bond, it will have sp3 hybridization. Question number 37. In Lasine test for the nitrogen in an organic compound, the Persian blue color is obtained due to the formation of very important question. Have you remembered that word I have given you? Ferroferrous hexacyanoferrate 3 ion. Yeah, that B1. Directly you have to remember that formula. It is a complex and informs you the time. Which of the following carbocation is most stable? Most stable, maximum carbon 1 will be the most stable, means which will have tertiary propyl group. You can see the B option. In the tertiary carbon, all the sides CH3 group is attached and the central carbon is having a positive charge on it. That will be more stable. Tertiary carbocation will be more stable among these all, right? See here, as I had informed you that maximum intervening bonds will be there, but on the above side hydrogen atoms, but here on the B option you can see carbon, all the three sides having methyl group, all the three sides not having hydrogen, so that's why this one will be the more stable. Now we are moving to the question number 39. The best and the latest technique for isolation, purification and separation of organic compound: crystallization, distillation, sublimation, chromatography. Chromatography is the right now modern method to separate of any organic compounds. You can go to the chemist, that chromatography process will be used. The following reaction can be classified: CH3CH2I plus KOH. It will give you CH3CH2OH. This is a nucleophilic substitution reaction. So this was our NCERT exercise solution. Hope all of you have understand. If you have any doubt, then please put your doubt into the comment box section. And hope if you have not understand, try to write all these answers in your notebook. As you will write, you will get more and more knowledge, and then we'll go ahead, and in the next lecture we'll especially go through the haloalkanes carbon atoms, that's called hydrocarbons, right? So I hope this chapter has been completed and all of you have understand about this all the concept. Thank you for watching. Don't forget to like and hit the subscribe button. That's all for today. Thank you very much.